Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topics, that is mass concrete. What is mass concrete? What is the procedure to control the temperature, and what is the procedure to monitor the temperature of the mass concrete? In today's video, I will discuss each and everything about the mass concrete. So stay tuned until the end to get the full information about the mass concrete. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject, that is mass concrete. So mass concrete nowadays, it's very much popular. It is used in every project, be it a foundation, pile cap, whatever. So first question is that what is mass concrete? That we need to know according to the IS code and the American Institute Report or ACI code. It is said any volume of concrete large enough to require measure to be taken to cope with the generation of heat and attendant volume changes to minimize cracking. So it is saying, it is not saying that this much of area, this much of length. So any volume, if you are thinking that the heat of hydration or the heat generating in the process, it is to be taken care to minimize the crack, that can be considered as a mass concrete. Now, why the heat is generating? Because it is an exothermic reaction. Whenever we are adding water into the mix, the water and the cement start reacting, and in the reaction process the heat is generating. So this heat, whenever the volume is much large or it's a large pore, the heat is become more. And if it is a large pore, or the thickness of the raft or thickness of the column or the pier is more, so it has the tendency that there is a temperature gradient can create. And if the temperature gradient can create, then heat will transfer from the higher temperature to the lower temperature, and then the cracks will generate, and also the shrinkage cracks due to the sudden change of volume. So we need to take care the concrete in order to prevent the cracks or the thermal gradient. So that is why the mass concrete is defined as any volume. If the designer think that it is required to be controlled mass concrete as a temperature control, then it is to be decided as the mass concrete. It is clearly inappropriate, therefore, to give a specific quantified definition of a large volume of pore, as this will be relative of the experience of the construction team and the scale of operation on a particular site. So it is depend on that. But generally, if it is become 1 meter, the thicker the slab or thicker the column, we are considering that it is a mass concrete, is a large pore. So then we are considering this to be taken care as a mass concrete, and the temperature variation due to this large volume we need to take in care. So these are the definition of the mass concrete is given in ACI 116R. The next is a design parameter. What is the design parameter for the mass concrete or the concrete? How we can design, because it's a special type of concrete. The large volume, there will be large heat to be produced, and due to this heat, there will be thermal crack. Now we need to design that concrete so that the heat of hydration will be less, and the temperature gradient that will also be less, so that there will be no thermal crack. So what is to be design parameter? It's temperature and temperature differentials. Now this is very important. One is the temperature of the concrete or the whole volume, that is, and the temperature differential or the temperature gradients. That means that whenever it's a large volume or the large pore, the core itself is become too much heat, and the surface or not that much of it. So what is happening? The differentials between the core and the surface is become more, and that is why the heat is transferring from core to the surface, and it is going to the environment. Whenever it is dissipating the environment, the crack is generating. So that is why we need to take care of the temperature differential also, not only that temperature of the concrete, but the temperature of the differentials of temperature or the temperature gradients that I will discuss later. What will be the maximum temperature is allowed. Then coefficient of thermal expansion of the concrete, that is very much important, that we need to take in care. Strain capacity, because whenever the heat is generating, the strain is generating. So how the strain or the restraint of the concrete is there, that is also to be taken care when we are dealing with the mass concrete. Then restraint to thermal movement and critical location, which may also involve assumption about pore size and casting sequence. So what will be the restraint category, that is also to be taken care when we are dealing with the mass concrete, and accordingly we need to play the size, pore size, and the casting sequence. So these are the four things we need to take in care whenever we are dealing with the mass concrete, that is temperature and temperature differentials, coefficient of thermal expansion of the concrete, strain capacity of the concrete, and restraint to thermal movement, because whenever thermal is the temperature difference, that is the heat movement, so there will be thermal movement, and that is to be restrained according to the size and the supporting sequence. So these are the four things we need to take in care whenever we are dealing with the mass concrete. For this mass concrete, you can check this book, Bamforth in Newman and Chu. This is a very good books, and I have taken the help from this book to make this presentation. So if you want to know in more about the mass concrete, it's a very good books. You can check that one. The next is the temperature control. Now I have understand that for the large volume, the temperature is rise. Now, so first things we need to do, we need to control the temperature. So there are temperature guidelines is given, then that is what will be the maximum temperature is allowed inside the concrete whenever we are dealing with the mass concrete. So temperature guidelines, where it is given, it is given in IS 16700 2023 in Annex C 1H. See what is it saying? The concrete used to in massive wrapped foundation, thicker shear walls and columns, deep beams, etc., shall be designed to appropriately control the evaluation of heat of hydration. So it is given the guidelines that it is a massive wrap foundation, thick shear wall, columns, and beam that should be taken care as a mass concrete, and precaution to be taken for the heat of hydration. The design of such concrete shall be done in such a manner that the peak temperature in concrete shall not exceed the 70-degree, and the thermal gradients within the concrete mass does not exceed 20 degrees centigrade. Now we are getting the parameter or the guidelines for the temperature. What is the temperature? That will maximum temperature can be raised inside the concrete is 70-degree, and in the core itself this temperature is become more in compared to the surface. So the maximum temperature should be maximum 70-degree, and what is the thermal gradients? That is 20-degree. That means from to core and the surface there will be maximum temperature difference will be 20 degrees. If it is not that, then the thermal crack can generate. So whenever we are dealing with the mass concrete, that to be taken care is very careful in India. That is in IS 16700 2023 Annex C1H, it's given the guidelines. While appropriately designed mock trials shall be conducted prior to actual concrete to demonstrate that these parameters are satisfied, temperature monitoring shall be done in structural element containing mass concrete by installing adequate number of temperature sensor to record temperature data on a continuous basis to verify that the temperature rise and thermal gradients are within the specified limit. So what it is also suggesting, that before doing the actual concrete, we need to do the proper mock-up, and for that proper mock-up we need to monitor the temperature also, that it is satisfying the criteria, that is a maximum core temperature is 70-degree and the thermal gradient is maximum 20-degree. So we need to do a mock-up itself before doing the actual concrete. So the temperature control, first we are getting the guidelines. Now how we can maintain this concrete temperature within the 70 degrees and temperature gradients with the 20 degrees. The first things what we can do, that the fresh concrete temperature or the placement concrete temperature, that is the best way to minimize the temperature generating inside the concrete. So we need to focus on that the fresh concrete temperature or the placement concrete temperature should be low as much as possible. So how we can make that one? There is there are various factors that we need to take in care to lower the heat of the temperature or lower the temperature of the placement concrete or the fresh concrete. First, low heat generating mix by limit the use of cement. Now, we all know that when cement, whenever reacting with the water, it's generating heat. Now, if we replace the part of this cement by the PPA or the GGBS, what will happen? Then the heat of hydration will be less. So there will be heat generation will be less. That is why whenever we are dealing with the mass concrete, this 100% OPC or the cement is not using. We are making the mixed design using the GGBS, microsilica or the PFE or the, that is pulverized fuel ash. So what is happening? That is slow down the heat of hydration process. As a result, the now total heat is producing become the less, so the temperature become less. So the first things we need to make a mix that is a low heat generating. Then supplementary cementitious material like GGBS to reduce the heat of hydration that I already discussed. Then aggregate with low thermal coefficient. That means that aggregate should have the thermal coefficient very low, so they will absorb of heat will be very less. Then shaded aggregate stockpiles. So whenever we are breaking the aggregate storage area, that should be shaded, so it should not be exposed to the direct sunlight, so that the temperature of the aggregate itself will be the lower. Then sprinkling water to the aggregate so that it will not take that much heat. Then another use is the cold water. So cold water, what is cold water? It is reduces the temperature. If we are using the 10 degree centigrade or 5 degree centigrade water, that means whenever we mix with the cement and the aggregate for the concrete, the heat exchange will happen. So whatever the heat will generate, as for the concrete, the cold temperature 5 degrees, so heat will be generating and the exchange of heat will happen. So the placement temperature will become less. So that is why the cold water we are using, or the better use to the ice flakes. Why it is better? Because the ice has the latent heat is 330 kilojoule per kg. Now, what is latent heat? Latent heat is that the heat required for a particular material from change the one state to another state. So whenever we are using ice, ice is the solid state and the water is the liquid state. So to change from the solid state to the liquid state, for this heat is required. So if we are using cold water, this heat will not be exchanged with the temperature. But if we are using ice, then along with the water temperature will be reduces along with this 334 kilojoule per kg, heat will be exchanged due to only change the state from solid to liquid. So it is always better to use the ice flake, or somewhere it is a liquid nitrogen also using. So but it's liquid nitrogen is expensive, that is not that much of used, but is ice is very much important for this mass concrete, that the placement temperature is become less. So that first criteria is to make mass concrete, that whenever you are taking concrete in the RMC plant, that should be ice plant. If there is no ice plant, we cannot use ice into the mix. So it is better that always fix ice plant, so that we can get the lower temperature, or the placement temperature of the concrete will be the less. Now, how we can calculate the temperature of placement concrete or the fresh concrete? So we need to understand that as low as possible the temperature of the placement concrete, then there will be a higher chances that the thermal maximum temperature in the core will not be that much. So how we can calculate that one? That there is a calorimetry you can make, and this calorimetry also you can find out the temperature, or the nomogram is there. In the nomogram itself, if you find out the ingredients temperature, we can find out easily the concrete placement temperature. Now this nomogram of the fresh concrete, here it is a sand temperature, here it is a coarse aggregate, here is a cement, and here is water, and then it is coming into the concrete temperature. Now here it is given an example. See, if the coarse aggregate sand temperature 10 degree, it is coming here the coarse aggregate, and then the cement temperature if you are taking 30 degree, then water temperature in between 20 and 30, 40, 30 degree, then my concrete temperature will be 20 degree centigrade. Now, if you want to lower, then again you have to use the, see here it is ice flake. So here it is ice flake. If you get 5 degree, if you're using 20% of ice, then it will come another 5 degree will be less, 20 degree. It is 40%, 10 degree. If we are using 60% of the concrete temperature will be 5 degree centigrade. So in from this chart, we can easily find out, this is called the nomogram of concrete mix temperature. From this chart, we can find out immediately what will be my placement temperature or the fresh temperature. On the other hand, you can find out with the formula that is also given, that is 0.75 Tc plus Mc. That is also this is the cement temperature, this is my sand temperature, this is 334 kilojoule for the ice. So from this formula also you can find out the placement temperature. Basically from this temperature formula, this nomogram is prepared. So here it is a very clear identification that what will be my placement temperature from this nomogram. You can play whether you can use 20% of ice, whether it is 30%, 40%, according to your requirement or according to your project specification. You can choose the temperature of the ingredient so that it should be your placement temperature as per the requirement. Say for example, if you want to use your concrete temperature or the placement temperature is 10 degree, then backward you can go here itself. 20% ice you need to use. Again, here it is will come then 30 degree. Here it is a 10 degree, and then sand temperature is 15 degree. So if you want to again 5 degree, then you have to use this 60, maybe 60% of your ice as water. Then it is coming 30 degree. In this way also you can find out in the opposite direction also. So this will be your placement temperature or the fresh concrete temperature. Now, why I want to reduce my placement temperature or the fresh concrete temperature? Because it will, when if it is less, then again it will generate the heat of the maximum peak will be the less. So from one graph we can show you, here it is time and here is the temperature rise. In the time, if the placement temperature is more, then this peak will be here, and then again it will come to the normal condition. If the placement temperature is less, then the peak will be less. So in that case, if the temperature is 40 degree for the fresh concrete, it may generate the heat up to the 70 degrees, say for example. But if the temperature of the placement concrete is less than this, maybe 20 degree, maybe this peak will be 50 degree, or else another things can happen. It peaks can come early, that may be 40 degree. So that is why it is our intention to as much as possible to lower down the placement concrete temperature. If we can make that one, our work has half done. So that the later stage, the heat of hydration also will be less, or the peak temperature also will be the less. So this way we can choose the ingredient temperature or the ingredient that is supplementary cementitious material, low heat material, or the thermal coefficient of the ingredient. So accordingly we can choose the mix, and accordingly we can place the concrete as low as possible whenever we are poured the mass concrete. So these are the thing in about the mass concrete, how you can temperature control whenever you are doing the mass concrete. It is for the placement concrete or the fresh concrete. Now another things we need to do, this hardened concrete. Now this is for the fresh concrete. Now the whenever the concrete start hardening or it starts getting gain the strength, then also the temperature also we need to be taken care. So that is why what is our IS 16700 guidelines? The guidelines is given that you need to do a mock-up before doing the actual concrete work. Why? Because in the mock-up we can evaluate what will be the heat of hydration is generating, or what will be the heat and what will be the temperature of the core, and what will be the temperature gradients with the core and the surface. So that is why we need to do a mock-up. So mock-up size, this may be 2 meter by 2 meter or 2 meter, or the actual internal dimension or depth. If is a 3 meter, we need to do the 3 meter, and we need to install the thermocouple inside the concrete. Thermocouple is that it's a device, it is measuring the temperature of the concrete. So what will happen? There will be two temperature grading temperature sensor or the thermocouple inside the concrete in the core. One is a top, another is one side, another is a bottom, another is another side, and another is ambient. So in this way, maybe it's a 6, maybe it's a 8, whatever the requirement, we need to install the thermocouple inside the mock-up. And after doing the concrete, it has to monitor what is the maximum temperature, what is the peak. So how long you need to monitor that one? That is depends on how, when this the temperature rises is going the downward fall, then only you can say now the peak, we are getting the peak temperature, that time we can stop the monitoring. So this way, we need to do the one mock-up before doing the actual concrete at site. So here it is given how you can listen. See, sensor in the center bottom, 100 mm from the bottom. So the bottom surface is the 100 mm. Sensor to the center block. Sensor to center top is 100 mm from the top. Again, side middle from it is saying 100 meters. So it center and the side at the top and the bottom, it's from 100 mm from the side. So this will be where we can place the sensor, and it's a data logger is there. It will show the temperature in 30 minutes, in 45 minutes, or now it is there. So we can find out in the mobile itself, the application. So we can see in your mobile also the what is the temperature, and same time with the help of the maturity measure, you can get the strength, how much strength is getting the concrete. So in this way, we can make a mock-up, and we can assess that what will be the maximum temperature and what will be the strain gain and what will be the temperature differentiation. So this is about the hardened concrete temperature. Now, when I have covered these, what is mass concrete, what is design parameter, and what is temperature control. Now we need to do the temperature monitor, because now we have done the actual mock-up, that we have done the mixed design, we have controlled the fleshment concrete temperature, and we have done a mock-up, and we have find out whenever we're doing actual work, then there will be very much from that we are not checking the temperature, or the temperature will not be beyond our limit. So what is with the temperature, how we can maintain that temperature monitoring? As the size of the wrapped or the size of the pore, according to that we need to choose that how much thermocouple to be installed inside the concrete to monitor the temperature. See, here it is like this, the thermocouple, this one, this going inside, and this loop is coming inside into the data logger. So it is monitoring the temperature, and it is sent to the data logger, and the data logger at any point of time we can check. Now see, in the actual scenario here itself, this is the temperature thermocouple is installed, and number of thermocouple also we need to check along with the requirement. What is my requirement? Now after thermocouple installation, or we have to do the concrete in the layer. So after concrete, what we need to do immediately? Immediately we need to do the application of curing compound, and then cover with polythene sheet. Then the insulation board we need to place over the concrete. Why? Because it has the tendency, or the concrete, or the it is a first law of thermodynamics, that the heat loss or the heat gain from the higher temperature, the heat will transfer to the lower temperature. So what will happening from the core, the temperature is high, and the surface the temperature is low. So from the core, the temperature will dissipate through the surface, and there will be cracks. So that is why we need to protect that the heat loss will not be from the concrete, and whatever that heat is generating, that will be inside the temperature concrete itself. So in that way, we can assure that the temperature in the core or in the temperature difference will be inside the concrete. So in this way, the data logger is given the data 60. This is a P on middle, P on bottom, P2 middle. So this way we need they will give the data in the data logger, and we have to analyze the data also. So whether we are getting as per the requirement or not. Okay. So these are the temperature control, temperature monitoring, and we need to do the on the regular basis, not on this maybe 7 days or 10 days. We need to take care that when the temperature is down falling, then we can say that we have achieved the peak. Then we can say, okay, now we can remove the shutter, or we can remove the thermocouple or the insulation. Now, maintaining temperature gradient, here is another thing we need to do. The maintaining thing formwork in place. So whatever we did, suppose we are doing the wrapped, I have shown the photographs, the curing compound, then polythene sheet, then insulation cover to make that one heat loss proof. Now, how we can maintain that one? There are something is maintaining the concrete that in condition, then due to the heat loss, there will be no thermal crack. So that is why the vertical surface should be in place. Now, there is again a catch. What type of formwork you are using? Whether it is a steel formwork or whether it is a plywood formwork. If you are using the steel formwork, that means it is a heat of a it is a conductor. Heat can easily pass through the steel because it is a good conductor. So if you are using the steel formwork, again it has to protect in the vertical surface also. But if you are using the plywood, it has not as much as conductor than the steel, so it has to keep the insulation, or it is required to be insulated from the vertical surface also outside, that also required. So how we can foam mats, blanket, insulation board, that I will show already the picture that we are using the insulation board, then sand on the polythene sheet, soft board, tenting and ponding. We can ponding the water, we can shade that one so that there will be no heat loss, or there will be no heat dissipation to the core from the surface, or from the core to the surface, and there will be no thermal crack. So these are the maintaining temperature gradient. Now I will show you something, that surface insulation. Why surface insulation is required? So this picture also taken from the same books. You can check this one. Now, this picture will give you a guideline. See, here it is saying tension at surface with the no insulation. If we are not giving the no insulation on the surface, then this much of tension will arise. And if it is tension is arise, then there will be a crack. Now, if you are using insulation, then need to see it is reducing like this. So it is always advisable that we use the insulation on the surface, so that the tension will not generate as much as compared to the no insulation. Now, another scenario is that tension increase to early removal of insulation. So now, if we remove the insulation early, or maybe you require to keep this one 21 days or 30 days. So what will happen if you remove early also? Then immediately the heat will dissipate it. So sudden dissipation of heat, that the tension will increase from here. Here it will have a key. What will happen? The slowly it will heat generating and it will dissipate it to the environment. But when you are controlling and immediately remove this insulation before the removal time, the sudden removal of this heat will transfer immediately, and the insulation, when the tension will generate more. So it is very much important to keep in mind that what is my period to keep the insulation on place, that is to be maintained or with the temperature. We are saying that accordingly, whenever it's a lower in the lower gradient, whenever temperature is lowering, that time only you can remove the temperature. Otherwise, it will again the maximum tension will created and crack will happen. So here is also given on guidelines. Then minimum pore dimension is, if it is 0.5, then minimum period of insulation 3 days. If it is 1 meter, 5 days, 1.5 meter, 7 days, 2 meter is 9 days, 2.5 meter, 11 days, and 4.5 meter, 21 days. But that is also you need to do a mock-up, and according to the mock-up, you need to place the insulation and remove the insulation as per the mock-up. Also, you need to check this temperature, and according to the as per temperature condition, only you can remove the insulation from its places. But it is the given the guidelines for the insulation. So I think I have covered as much as possible about the mass concrete. Let's summarize. What is mass concrete? What is the design parameter? What is the temp? How to control the temperature of the concrete is the hardened concrete temperature, and as well as the fresh concrete temperature, and then temperature monitoring using the thermocouple and the insulation blanket. Then maintain the temperature gradient. Then the surface insulation. And I hope you find it useful. And if you find it useful, please kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So mass concrete is a huge subject. It cannot be explained in a single video, but still I'm trying to uh, give some ideas about the mass concrete, and I hope you find it useful, and I'm waiting for your valuable comments so that from your valuable comment everybody will be benefited. And I'm waiting for your comments so that from your comment I can also make a new video of like quality control and construction. And thank you once again for watching me.